We have seen a great number of redistribution examples throughout our discussions. And one of the things we have to be aware of is that when we perform redistribution on a single router between two different routing sources, we usually don't have too many problems. All we're really losing is the ability to see the true metric or the true path once we get into that other routing domain. However, when it comes to having multi-points of redistribution within our organization, so two or more routers where redistribution is occurring between the exact same routing protocols, we start to see some various problems and some challenges arise, such as routing loops, whereby our routers learn the incorrect information from different routers because of various reasons. It might be administrative distance based, for example, and as a result, we are trusting the wrong source of information now instead of the appropriate or correct source of information. In addition, and because we are losing the overall visibility of the complete routing domain, we are now potentially choosing suboptimal paths through the network to get from point A to point B, which is in a completely different routing domain. We still have visibility within our own routing domain, but it's outside that routing domain where we lose that visibility. We definitely have incompatible routing information. There's no question about that. What EIGRP uses and RIP uses and OSPF uses and BGP uses is completely different when you compare them to each other. Therefore, when we perform redistribution, we are essentially just taking that route, throwing it into the new or the routing domain, and we are modifying values or using default values, which don't really equate to the values that were being utilized in that other routing domain. And it's all because of this incompatible information that we have. So again, losing visibility. And none of the routing protocols converge consistently, meaning EIGRP converges differently than OSPF. How fast can EIGRP converge by default? Well, we assume a neighbor is dead by default with a 15-minute dead timer, whereas OSPF by default is 40 minutes in our Ethernet, or 40 seconds within our Ethernet environment. So let me repeat that. EIGRP is 15 seconds and OSPF is 40 seconds. So right off the bat, we can see that EIGRP should technically converge quicker than OSPF. And then we have BGP, which is one of the slower routing protocols to converge out there. Well, we have different solutions in place that are going to help us with these challenges. And as we've seen already, we've talked about distribute lists, which give us the ability to define what will be redistributed, and we can permit or deny certain routes at certain entry or exit points within that environment from being redistributed. We focused on route maps as well in our discussion, whereby those route maps can give us granular control of what is happening at those redistribution points. So if we end up with routing loops or we end up with suboptimal path selection, we can use those route maps, which really is the best option because the route maps give you more granular control over the specifics of routing information. So if we want to modify a metric coming in at one router, so that way there it is more preferable than the metric coming in at another router, we can, and that can help us prevent, for example, routing loops or prevent suboptimal path selection. We'll see some of these examples here shortly. We can manipulate the metrics directly at the redistribution point without even using route maps, as we've seen. And we can also manipulate administrative distance. So we'll take a moment here and look at administrative distance as well in our forthcoming discussion. But first of all, let's focus on the metric itself. And we've seen this earlier, but we're revisiting it here because it might make more sense to you now, but it's something you really have to be aware of, and that is, at this point in time, we're performing redistribution on R2 and R3, so we have this multi-point mutual redistribution that is happening between our two routing protocols. So if we pretend that this happens to be EIGRP, and this is OSPF, well, what happens when we redistribute from EIGRP into OSPF? By default, we get our costs of 20 that are injected at those redistribution points, and they are going to have metric types of E2. So we are dealing with these E2 routes with metric types of 20, and they are being injected into this OSPF process. Now, from R1's point of view, what is the best exit point? from an earlier discussion we had on OSPF E1s and E2s, recall that in this case, they are equal E2s, they have equal metrics, but the path to get to the autonomous system boundary router is different. The cost here is based on a 200 meg link, and the cost here is based on a 100 meg link. So in this example, R1's definitely going to choose R2 as the exit point out of the environment. Is that the best way? No, it's not. This is suboptimal routing. This is our problem here. We have suboptimal routing because of this 10 meg link. This 10 meg link is really, really slow, whereas this 200 meg link is much, much quicker. So from OSPF's perspective, though, it's making the right decision. However, in reality, it's not making the right decision, and it's because it loses the overall visibility of what's happening in the EIGRP domain. That's why its decision is not optimal. So this is suboptimal path selection that is going on here, and we as administrators have to recognize this. And once we recognize it, then we can manipulate, for example, the metrics as they're being introduced into the routing domain. So we might set the metric as 30 here instead, leave it as E2, and set the metric as 20 here at the redistribution point and leave it as E2. And now what is R1 going to prefer or choose? Well, it's going to choose the exit point out of the domain that has the lower metric. And in this case, it is R3. So we are going to go to R3 in this example as the exit point. So traffic's going to be routed through R3 and then go across the 200 meg link instead of the 10 meg link. So being able to recognize this as a problem and understand that you would have to modify metrics to make it work or modify the metric type. Metric type, though, would be all dependent on what your internal metrics are as well. Because if you leave them both as a metric of 20 at the introduction point here and you change them to E1s, well, 20 plus the cost of here and 20 plus the cost of here, it's still going to be taking this path because this combined here metric is going to be better than the metric going through R3. So we have to be mindful about the metric introduced and potentially as well as the metric type that we're going to be using.